students, today we learn Archimedes principle in the physics. So this is a required and maybe syllabus for 10th class and intermediates and intermediate, and is the basic info knowledge is required for the things, theories, concepts depending on that Archimedes principle for JEE students and NEET students. Okay, coming to that Archimedes principle, that statement definition. When a solid body is partially or completely immersed in a fluid, the fluid exerts an upward force on the body, whose magnitude is equal to the weight of the displaced fluid. The bottom also another the thing is the force exerted by the fluid on the solid body is called the buoyant force or buoyancy or thrust or upward force. So what we can understand from this statement, we can see here, for example, I took a glass of water. This glass is filled with water and it is put in this a small plate. What the statement of the water found out by the Archimedes is another small bottle. So this is also filled with water. If I kept on the surface of this water, if I kept this small bottle on the surface of the big glass water surface, I need to hold this small one, and again I need to apply some force in the upward direction, then only it will be kept on the surface of the water. Next step, you can understand that, you see that if I immerse this small bottle, let us assume this upward force, I hold this small one on the surface, let us assume in the upward direction by this my hand 5 Newton force. Okay, suppose if I immersed this small bottle into the water, please observe that a small quantity of water will be let out from this bottle. How much quantity of water let out from this big bottle? Whatever volume of this small bottle is immersed, that much of volume of water will be let out from this glass water. So what is the pressure, what is the force that is exerted by that water, we can calculate. So what we can understand here, suppose if you immerse this small bottle into the water, it needs to some space. What is the volume of that space? So whatever volume of this small bottle is there, that much of volume is required to accommodate this bottle, that much of water will be let out from this big glass, so that it can find out the place, it can find out the space. Okay, if I initially 5 newtons, suppose it half of this depth is immersed, obviously the 5 newton is reduced to some extent. Let us assume that 4 newtons, that this water is exerted upward direction, so that force what I applied in this direction, upward direction, that force can be reduced, so that water exerted in upward direction 1 newton. Suppose if I immersed completely this bottle, you see that water will be let out from the big glass. So whatever volume is there, that much of water will be let out, so that it can find out the space in this water. So obviously this applied force is reduced further. It is, let us assume 3 newtons. So 3 newtons. So now I can hold this small one in this position. I need to apply only 2 newtons. So remaining 3 newtons, so that is applied by this water, by this water in the glass water in the upward direction, that applied force in the upward direction, that is called buoyancy force, buoyancy force, or buoyant force, or buoyancy force. So I can I hope what is the force that is the applied by this water, that can calculate, how to calculate, you know that this volume of this small one, that much of water will be let out, if you know that volume of this one, though the same quantity of volume of water will be let out from this glass, you find out that water weight, that much of weight is a force of one kind of force, that much of force is exerted in the opposite direction by this, by that fluid. You can see that this is not submerged, it is not immersed. Why it is not immersed, we can understand later. The same thing is here. Once again I am explaining here. This is the glass of water, this is the water, small one is filled with water. So I hold this bottle on the surface, I need to apply in upward direction 5 newtons. Suppose this is immersed a little bit depth of this height of that one, I need to apply only 3 newtons. Why? Whatever that 5 newtons is reduced 3 newtons. What about the rest of 2 newtons? This water is applying in the upward direction 2 newton force. That's why this force is reduced to 3 newtons. 3 newtons. So this one, this 2 newtons force we can calculate. That already I explained. So because of the put it water, whatever volume is there, that much of volume will be let out from this glass. That let out water weight is nothing but equal to 2 newtons. Here, if you further, it is immersed up to neck, this immersed in this water. So volume of this bottle is increased, so that more volume of water will be let out from this glass. So that this upward force is increased. I can only apply 1 newton. In the bottom, this water is applying in this direction upward 4 newtons. 4 newtons. So I hope you can understand. So here another example is the fixed support. Here there is a rubber string. Here I can attach a small weight, so that rubber string is stretched by 10 centimeters. Here I can put it a glass of water, put it here under this weight, so that the length is reduced to 8 centimeters. Why? When it why? So because of this weight, rubber string weight is put in the water. Upward, this what is exerted upward force. That's why that length is reduced to 8 centimeters. So this is the meaning of the Archimedes principle. Upward force by this fluid exerted, that force is called buoyant force or buoyancy force or upward thrust. I can explain once again. You can, what is the how much the force is exerted by this water, when we are putting this bottle inside, it needs some space. That space is not equal to volume of this bottle. Obviously, let us assume this container is filled with water. So once you put it, that water will be let out. Automatically let out. How much water is let out? Whatever volume this container, this bottle has, that much of water is let out from this container. That volume of water weight to be find out. That we can find out that weight, that much of weight, that my weight is nothing but force. That force is exerted in this direction, upward direction. So upward direction. That we have to understand. That force is nothing but this fluid applied force in the opposite direction. That force is nothing but buoyancy force. Okay, by taking one numerical example, we can understand in better way. By solving this problem, you can understand in a better way. A bottle of mass 2 kg and volume 2.5 into 10 to the power of minus 4 meter cube is completely immersed in water. Find the buoyant force exerted by the water on the bottle. Density of water is given 1000 kg per meter cube. This is the problem. So this is the container filled with water. This is the another bottle that is immersed in container water, completely immersed in So this immersed portion of bottle, completely immersed, that bottle, the small bottle, volume equal to 2.5 into 10 power of minus 4 meter cube. Mass of this bottle equal to mass of bottle equal to 2 kgs. So we know that because of you are put this bottle inside, immersed in bottle inside this, we know that whatever volume volume equal to 2.5 in 10 to the power of minus 4 meter cube. This much of water will be let out, then only it can find out the place, then only this bottle can find out the place. Otherwise that much of water is not let out, it cannot find any place, it is cannot put in water container. So this is the water, this much of water will be let out, 2.5 into 10 to the power minus 4 volume of water will be let out from this container, so that it can be comfortably placed inside. So this is the let out water, this is the water, let out water, this is a displaced water, this displaced water weight to be found out, that much of force is applied in the opposite direction by this water in this container. So coming to this mass of displaced water, we have to find out what is the displaced water, this much of displaced water. This volume is nothing but 2.5 into 10 to the power of minus 4 meter cube volume of water will be let out, because this is the volume of that bottle, so that much of water will be let out. So therefore mass of displaced water, mass of displaced water equal to mass density equal to, we know that mass density of water equal to rho is equal to mass of bottle divided by volume of water. From this rho density, mass density equal to mass by volume. From this mass equal to rho into mass density into volume of that bottle. So from that I have to apply that equation, mass equal to rho mass density into volume. So we know that volume, the mass density he has given water in this container. So mass density we know that 1000 kg per meter cube, into volume 2.5 into 10 to the power minus 4 meter cube. So you can get cancelled meter cube, so that if you simplify this one, you can get finally 0.25 kg. This is the mass of the water displaced. So this much of volume of water, mass equal to 0.25 kgs. Okay, now we can find out the weight equal to mass into acceleration due to gravity. Weight of the displaced water equal to W. Weight equal to mass into acceleration due to gravity. Mass already we calculated, that is the 2.5 mass equal to 0.25 kg into acceleration due to gravity equal to 9.81 meter per second square. So that if you simplify this one, 2.45 newtons. We know that kg meter per second square is equal to 1 newton. So therefore we can convert this 2.45 newtons. This much of force is exerted in the opposite, in this direction. That force is nothing but buoyancy force. Okay, so I hope you can understand in better way. Okay students, coming to another topic, floating bodies. So the floating bodies is nothing but, you see here what is happening here. The small one is not immersed in this water glass, without there is no support, but it is on the floating, not floating, it is in the suspended on the surface, on the top surface. Why it is suspended without immersed in this water, that we can understand from this concept. Okay, a floating body is in equilibrium. Let us assume this is in equilibrium. This one is in equilibrium. It is not moving or immersed in the water. So in this position it is keep on there for forever. So in which condition it is possible, let us understand. So this is the, you take it that glass. In this glass, let us assume you take water. So there is a small weight, small object. Object is put inside the glass of put inside this glass so that what is happening, let us assume, obviously as per the previous Archimedes principle, once that object is immersed in this water, obviously there is upward force. That upward force is acting on this object. That force is nothing but buoyancy force. Let us say that is a B force that is applying by this liquid fluid or water on this object in this direction. So how much force that is acting in the upward direction, that we have already explained in the Archimedes principle. Whatever volume is there of this object, the same quantity of volume of water will be let out. The let out water weight is nothing but acting in this direction, upward direction. At the same time, this object weight is acting in this direction by the gravity, by the earth. Earth is exerting pressure, a force on this object, so that that weight is acting in this direction. Suppose this is in the equilibrium condition, as I shown just now. It is equilibrium condition. Equilibrium condition means the weight of the displaced liquid equal to weight of the body. Then only it is in the equilibrium condition. For example, so you take it one. This is in the equilibrium condition. It is equilibrium. The weight of this object is equal to the force exerted by the water in the upward direction. So if it is the same, equal, then it is in the equilibrium. If the force applied by the this object, this object or weight of this object equal to that force exerted by the water in the upward direction is equal to same, then it is in the equilibrium condition. So therefore, buoyancy force equal to weight of the body. So let us assume that here, suppose the weight of the body, let us assume that is the 2 newtons. Obviously the buoyancy force is also 2 newtons. Then only it is in the equilibrium condition. In case that weight of the body is greater than the buoyancy force, obviously it is going down in the water, and it will go to the bottom of the glass and it will be settled down. So okay, the object weight is more than the buoyancy force. Obviously it is settled down bottom of the glass. That will be there. That means suppose the weight of the object is 5 newtons, the buoyancy force is 2 newtons. So obviously that object is settled down at the bottom. So this is the floating bodies. You have to understand the floating bodies. The small with this example. Okay, students. So another topic, the condition for floating in terms of density. So the floating condition we can find out in terms of density. Let us assume here buoyancy force is greater than the weight of the object. So you can see here, look at here, you can understand here, this is the object, this is the solid object. Obviously we know that weight of this object is acting in this direction. Obviously this water below this object surface, this water is pushing, acting, exerted force in this direction, that is nothing but buoyancy force. This is called weight of the object. They are acting in the opposite direction each other. Let us assume this buoyancy force is greater than the weight of this object. Obviously what is happening? That object is on the water surface, The buoyancy force is greater than the weight of this object, that's why it is on the water surface. Suppose this weight is greater than the buoyancy force applied by that water, it is getting down. It is immersed in this water bottle and maybe settled down at the bottom of this glass. Okay. So in the same way, so we can express these floating condition in terms of density. You can please look at here. Suppose that this buoyancy force is greater than the weight of this object. Suppose here buoyancy force, let us say that denoted by B and denoted by B. So the density of water, obviously this water is exerted in this direction, on this object. So that is the density of the water. Let us say that rho L liquid, L is different liquid, water, rho is density. So we know that density equal to mass by volume, that is equal to mass. I can write in terms of weight by G. We can understand here buoyancy force equal to B, that is the mg. From this mg, equal to buoyancy force B by G. This B is nothing but buoyancy force, that is nothing but weight of the water exerted force on this solid body. From that you can take it here, rho L equal to B by G. W is nothing but B, weight equal to nothing but B. So G, acceleration due to gravity, so that is equal to volume. This volume is nothing but volume of this object. That much of water will be let out from this glass. That weight of that let out water is nothing but this one. Okay, so V. So from this equation I rearranging this equation. So you take it out, V in this left side, rho L into V equal to B by weight by buoyancy force divided by G. So from this B equal to, you take it to this G, this left side, so that buoyancy force equal to rho L Vg, that is acting in the upward direction, this one, upward direction. Next, the density of the solid body. So let us take this body's weight is acting in this direction, downward direction. So let us say that the density of the solid body, that is, let us say that rho. So rho equal to, again you can write mass by volume. Here this mass by volume. So mass is written in terms of weight of that body divided by G. Like this. Okay, G. So again this is the volume. So here weight of this object acting in this direction, volume, weight by volume is equal to density of that solid, V, volume of that object. Okay, for this equation is rearranged, rho into V is taking this side, W by G. That W is nothing but weight of this solid. So that W equal to, you take it G this side, so that rho Vg, that is acting in this direction, downward direction. Now, so what is the condition here? Buoyancy force is greater than the weight of that object, so that we can you can write here buoyancy force equal to weight of that object, So rho L Vg greater than rho Vg, you can rearrange that one, rho L Vg, V volume, G constant either side, so that they get cancelled. Finally you can get rho L is greater than the rho, so that I can write here rho L greater than rho. So therefore from this derivation we can understand that this floating condition we can express in terms of density. What we can understand here, because of this density of that object is less than the buoyancy, the liquid density, the water density. Okay, this solid density is less than the density of that water. Obviously this object cannot be immersed, that will be floating on the object. If that object density is greater than this water, that object is immersed in the water in this glass and maybe settle on at the bottom, in case rho L equal to rho. So again that object in equilibrium condition, like this. This is equilibrium condition like this. Rho maybe in the, it is not submerged, it is not getting down, it will be like this equilibrium. Another thing is For example, you can take for example these things. So you can take for example milk, water. Water get dissolved in the milk, vice versa, vice versa. Why? Because the density is same. If that density is the same, one specific gravity of the water we know that, density of the water we know that 1000 kg per meter cube. At the same time, milk is also almost 1000 per meter cube, 1000 kg per meter cube. Then only they get mixed. They get mixed like that. Some of the fluids, if their density is the same, they get mixed together. They get mixed together. Like that, blood, water. Like that, you can take so many examples. Coconut water, water. But you take in case the density of the oil. If you take is the oil density. Oil is, you see that if you get mixed in the water, that oil is floating on the water. Why? Because this density of the water is less than the water density. So then that fluid is floating on the, it is not get mixed with the water, they are floating on the water. You can see that many in houses, suppose you put oil in water, that oil is floating on the water. Or you take cleaning of the vessels, that oil is floating on the water. Because what is the reason? Because its weight density of that oil is less than the weight density of the water, then that oil is floating on the water. So I hope we can understand condition for floating in terms of the density.